So I'm very excited. This course is part of a course that it's part of a number of courses that I've developed since about November of last year. And this is actually the first time that I've had the opportunity to give all of this content in person to you. So this is really exciting. The content of this presentation is actually adapted from the presentations and the courses that we give to our actual clients that come to us at GuidePoint. So it's all really high quality stuff and super relevant to the modern kind of state of the application security space. So first, a little bit about me. My name is Charlton Trezevant. I'm a senior application security consultant at GuidePoint Security. I come from a development background. I started in that type of role about 7 years ago, and I shifted into consulting about 2.5 years ago or so. So a bit about GuidePoint itself. We were founded in 2011. Our headquarters is in Herndon, Virginia. We have over 3,000 customers and more than 650 employees. And we're trusted by organizations across all industries. So we serve 40 of the Fortune 100 and about a third of the Fortune 500 across all different types of industry verticals, from restaurant chains, large financial services companies, automakers, real estate, you name it, we are there. And we also serve about more than 50% of cabinet level agencies for the US government. We're a very engineering heavy company. More than 70% of our workforce are engineers. And all of our different consulting related services are stratified, not just in AppSec, but also across cloud security, GRC, threat and attack simulation, IAM, and incident response. So now that I've gotten the requisite sponsor plug out of the way for my employer, let's talk about the agenda. Here's what's on deck. So we're going to start with a bit about security itself. I always like to kind of level set with what is security? Everyone has a slightly different conception of what that means. Then we're going to move forward and talk about application security programs. We'll talk about some AppSec standards that are useful to developers. I'm going to give you a bit of an introduction to threat modeling, and then we'll close it out with some discussion about feedback loops and metrics, where application security programs can actually serve your needs as a developer and help you work more effectively. So what you should expect, this is a very conversational type of class. I'm not here to kill you with the PowerPoint. So feel free to ask questions. And again, all this is based on real world examples and real world experience. So not super nebulous. So speaking of real world experience, I know a lot of you, or pretty much most of you, come from a development background, or you are developers. When I first started coming to Tampa Devs, I was one of like 3 people total that was security. And so I'd like to kind of portray the state of application security, if you will, with a hypothetical middle school lunchroom. So we have security folks over here and we have developers over here. And it's very difficult to get them to work together effectively. There's sort of this demilitarized zone in between them, if you will. And so typically what my job is as an application security consultant is to kind of just do ninja jumps across the DMZ to kind of unite these two disparate groups that are actually not so different, but they kind of hate each other. So raise your hand if as a developer you've had, like, I don't know, releases and schedules blocked by your wonderful security team at work. I see at least one. I see another. Yeah. So needless to say, there could be a bit of animosity between development teams and security teams because they can step on each other's toes. And frankly, a lot of the security folks are not entirely on board with like the developer workflows and kind of agile processes that you actually need. So you just kind of, I don't know, you get thrown a pile of bugs that are security related that you then have to turn around and go fix. And it's just like a hairball and it's no fun. So what I am trying to do with this course, we want to prepare developers to confront AppSec problems effectively. I want to educate you all about some of the tools, techniques, and strategies that exist within AppSec that pertain to your work. And ideally, the overarching goal is to build a more effective partnership between AppSec teams and developers. What I don't want to do, and if you've ever had to sit through like an annual security training at your company and they just kind of tell you like, oh, the sky's falling and you're all going to die and get hacked. That's not what this is. And it's also not an excuse to just make a bunch of developers sit through security jargon through for my own amusement. So without further ado, let's get into this. So a primer on security. So security itself really has very little to do with computers on a fundamental level. And what I mean when I say this is that, like, you probably already have an intuitive understanding of the security space because security itself has existed for much longer than computing has. Basically, for as long as human beings have had things that are valuable that they need to protect. So when we're approaching security problems, the first thing that we do is we start by understanding and evaluating risks so that we can then prioritize improvements to our software. So we think about things like, what are some of the attack scenarios that could happen? How likely are they to happen? And, what are the costs of them happening? So risk is very subjective, and it's very context dependent as well. So, depending on the type of application that you have, if you've got something like a app that processes health records, is probably there would be a lot more fallout if there was a breach of that application versus if it was something for people to share their favorite cat photos. So to understand risk fully, you've got to look at you've got to look at your application through a security lens from the standpoint of like the interdependencies of the technical personnel and business perspectives there. And you've also got to think about trust, and trust can be transitive. So if you're familiar with like chains of trust, like in public key cryptography, but in a more human sense, if you think about, like, say you've got a friend that trusts another person, and then you kind of implicitly trust them because your friend trusts them. So as far as thinking about trust in depth goes, our applications don't exist in isolation. If you're developing software for a business, like, you're not just making software for the absolute hell of it. It serves some kind of function, and there are sets of teams underneath that actually support it from a technical standpoint and for the rest of the business. So from an infrastructure standpoint, you've got whatever database, maybe there's like customer or user data that you're storing and processing for your app. Maybe there's financial information and what have you. You've got different teams that support the actual application itself. So you've got developers, obviously, systems admins, maybe you've got site reliability engineers, auditors, etc. And then depending, again, on the industry that you're in, you probably have a number of different regulatory and compliance considerations as well. So if you're processing credit cards, for example, you've got to think about PCI, health records, HIPAA, et cetera, et cetera. So again, putting everything in context about all of the kind of interrelated aspects here that could affect you, whether that's people, whether that's like the servers and the software itself, whether that's regulations, is all important when we're trying to categorize risk. And then finally, security is also about vulnerability, which, you tie that back to exposure. So you think about entry points. Where do people interact with your application? Is it a web UI? Is it an API? Is it a mobile app? Where are you storing and processing sensitive data? And where are the valuable assets located? Whether that's compute resources, whether that's customer data, it depends. And then also consider likelihood, right? So not all attack scenarios are created equally. So you might think, I don't know, like what's the likelihood of someone attacking your application, say through the web front end, versus a team of highly trained space aliens breaking into your data center and stealing the server that actually hosts it so that they can get the data off? I would say that the latter case is pretty unlikely, but that's kind of a hyperbolic way of thinking about this. So think about how easily could an attacker exploit a flaw? How much time would they need? Does the exploitation of that flaw require extreme skill or maybe expensive equipment? How easily can they access the resource? And would they have a motivation to do this in the first place? No one's going to sit down and spend 30 hours and tens of thousands of dollars to breach your cat photo application unless they're going to get something out of it, right? Whereas if we're talking about something that maybe has a bunch of like bank account numbers and like other sensitive PII, there would be a much higher level of motivation from an attacker standpoint to actually go after that. So finally, from the impact standpoint, that's broader than just technology alone, because again, businesses don't just create software for no reason. It exists as part of that whole organization, and it affects other people in other departments. So obviously there's like monetary costs, business recovery costs, maybe there's new audit requirements that roll out, marketing and PR, you kind of have egg on your face after a breach. and so on and so forth. Uh, so it's about more than like, oh, we just had a bunch of database records dumped. You can think about it sort of in this tree, right? If this is risk, we've got risk is made of, you've got impact, probability, and ease of exploitation. Impact, you've got your damage potential and the number of affected components in the app. From a probability standpoint, you can lower the probability of attack by adding mitigations. If you think about, like, you've got a table with an expensive necklace on it, that would be pretty easy to steal. Whereas if you put a safe there and you put the necklace in the safe, it makes it less likely to steal it. And then finally, the ease of exploitation as well. So we've got this castle metaphor, right? And how many of you guys, this is like the classic like metaphor that's used for security, and it sucks. And I'll tell you why. So, we think about this castle, right? You've got these high walls, you've got the moats, you've got the watchtowers. There's like the one entry point with the drawbridge. This is a pretty good castle, right? By all accounts. But like at this point in time, if you're trying to build a castle to keep your, I don't know, whatever is important from getting attacked, I mean, couldn't you just like parachute some people in here, right? Like in the year 2022, like the castle's really not the way to go about it. You want some sort of like, secret underground bunker. And why is that, right? It's because security is actually continuous, right? So it's not a static end state. It's not like you build the castle and it's like, all right, I am set. No one's ever going to get in here. So it's not there's not a perfect end state that you can attain. And so really effective security programs, they prioritize resilience and adaptability over trying to construct something that's like quote unquote perfect. So let's give you a real world example. So prior to the Oklahoma City bombing in 1995, which is a very tragic event, there were actually no consistent security standards for federal buildings. At this point, in this day and age, when we think about federal buildings, we're like, that's very high levels of security, right? But prior to this point, that was not the case. So after that event happened, you think about up to that point in time, you've got about 1,200 different federal facilities across the United States, constructed at different points in time with different levels of like security controls and mitigations on them. And all of a sudden, you've got to completely roll out an entirely new set of security standards to cover that. So in order to approach this problem, the Department of Justice actually created a standards working group. And the first thing that they did was they assessed the security measures and proposed new minimum requirements for federal facilities by actually going out and inspecting each of those facilities and seeing what they had in place at that time. So the GSA, which is the General Services Administration, they went out and they did research and a feasibility study on each of those 1,200 facilities and issued a report at the end of that research to basically figure out what was possible and how much it would cost. After they issued the report, the president at the time directed all agencies to begin facility upgrades. So they allocated a budget, they set timelines and things. And the president also formed committees that were dedicated to maintaining and developing security standards from that point onward. And the reason that I bring all of this up is because, again, we can learn a lot about computer security by looking at the larger domain of security outside of just like the digital realm. So in this case, there was an unexpected tragic event that created a need to account for new threat scenarios. You think back to the castle, the standards they had in place were no longer adequate. They needed to go and completely, rewipe the drawing board and start over. And so they set up an organized modernization initiative and performed a very well organized set of risk assessments and analysis of the existing assets. They distilled those findings into a report where they reviewed everything for cost and feasibility prior to implementation. They provided the asset owners, so the managers of the facilities, with the revised standards and funding to actually implement the new requirements. And they created a new management structure to govern and oversee those new standards into the long term, to prevent the recurrence of that happening. So again, you've got an intuitive understanding of security as it is, and security challenges are present, all through our life and society. Anytime, there's something that we've got to protect that's valuable, security is a relevant consideration. And real world examples teach us valuable lessons about threat modeling, risk assessment, and governance processes to basically confront these challenges, and that's true approaching application security. So, any questions before I move into the application security programs piece? If you've got any questions, you can just raise your hand at any point, and you can just talk, and I'll, call on you. Right. So, what is application security? So, a lot of the time, when I tell people that I do application security, they just assume that all I do is penetration testing, and that's part of it, right? So, I'm not purely like a penetration tester. I do a lot of strategic work now, but the scope and kind of scale of what constitutes application security is often misunderstood. So this is the Wikipedia definition of application security. And the important bits that you should take away, it's AppSec is all tasks that introduce a secure software development lifecycle, right? So that is a very like wide-ranging set of things. It's not just pen testing. And the goal is to improve security practices, and through that to find, fix, and prevent software security issues in applications. So it encompasses the entire software development lifecycle. It's not just, once you've actually got the thing deployed and you throw some red teamers at it. And so this is kind of what that looks like. So these next two slides, these are, the actual application security services offerings that we have at GuidePoint. And it's probably too small for you to read here. But basically, if I'm going to categorize these, this is a pen test, this is a pen test, this is sort of a pen test, this is threat modeling, this is a strategic task, this is training, and this is continuous scanning, right? So you'll notice that like only 3 out of 8 of these are actually pen testing, and the rest are strategic and training. And so if you think about, broad categories for those types of tasks, we can kind of split it across 3 categories. So we've got things that are more proactive. So that's the kind of stuff that you can do maybe before you've actually implemented the application. So early on in the development process. You've got more reactive things. So stuff that you can do once the application is built, or maybe in response to some sort of security event, revisiting the thing that you've already constructed. And then you have stuff that happens out of band. So that's more your trainings and stuff for your development teams, teaching them how to develop more secure software. And we can put that sort of on our SDLC diagram. So your requirement analysis and design, that's when you do stuff like threat modeling, architecture review, or gap analysis, like SDLC gap analysis. And then down here, obviously in order to like test something, it needs to exist. So this is from implementation through like the continued maintenance of your software. That's where you'd have pen testing, static analysis, etc. So in a nutshell, what you're trying to accomplish with AppSec is more comprehensive than just pen testing. And in fact, it's applicable across the entire software development lifecycle. You've got different types of offerings, typically from AppSec, whether it's consultancies or like just different types of products that are best suited to different stages of the SDLC. And the value in the proactive approaches early on are that you can systematically catch and prevent entire classes of security vulnerabilities pretty early on. So speaking of, let's talk a bit about standards. So I'm kind of a fan of standards. If you think about building codes, fire codes, electrical codes, these are all pretty good, right? And they exist for a reason. They exist so that we don't go down in flames on a plane, or like this nice building doesn't collapse around us, ideally, if it's done right. So to kind of facilitate some of the same safety goals in the software development space, there are a number of application security standards that have been made for developers to take advantage of. And the idea is that security professionals want to make application security easier and more approachable for everybody, right? So to achieve this, we've got clear and consistent guidelines from a number of different bodies that have best practices, and they're excellent tools, if you want to just pick them up and review your implementation that maybe already exists, or perhaps you're trying to figure out, hey, how can I implement authorization in a way that follows best practices? You can pick these standards up, you can review them, and basically rest peacefully in the knowledge that that's backed by a community of respected, competent security professionals, as long as you follow the standards guidance. So another important distinction. So there are 2 types of security problems in software. There are bugs and there are flaws, right? So bugs are implementation failures that cause a system to operate in an unintended manner and create a security issue. So you might think about input handling bugs. Maybe you have a SQL injection flaw because you weren't sanitizing user input and you're not using parameterized queries, or issues with your logic, or issues with validation. Uh, here's some famous CVEs relating to those. On the other side, with flaws, those are more design failures, right? Those arise when a system operates as intended, but the design of the system or the intended mode of operation of the system creates a security problem. So that's, for example, like maybe you just didn't put any kind of authentication on a sensitive piece of functionality in your app. Or maybe you decided, hey, we're not going to store user passwords in a hashed format because we want to be able to send that to them in an email if they forget it, right? Or maybe you're only performing input validation on the client side and not actually doing that check on the servers as well. So again, like two different classes of issues. One is implementation related and the other is design related. So to help you from the standpoint of design, we've got one great standard, which is ASVS. This is published by the Open Web Application Security Project, also known as OWASP. And this provides a basis for testing web application technical security controls, as well as any environmental controls that you have around that. So you can look at the application itself and the way that it implements different things. And you can also look at the actual environment that it's deployed in through the lens of the standard. And it provides developers with a really comprehensive list of requirements for secure development. Now, the goal of ASVS is to basically normalize the range in coverage and the level of rigor available in standards material when you're performing audits on especially web applications by using something that's a commercially workable open standard. So some examples of where you would want to use ASVS, maybe you're using it as a metric if you're trying to actually categorize, flaws that you're finding in the app or different types of risks that you've identified, or maybe as guidance if you want to, you're designing a new application, you want to think about the security controls that you should put in place. You can also use it during procurement, say, if you're approaching a third-party vendor and you want to hold them to some kind of standards compliance for security, you can use ASVS for that as well. We also have CQE and CWE. So you're probably familiar with CWE. Both of these are from MITRE. And CWE is a list of like software and hardware weaknesses. And CQE is more a list of software quality measures that aren't necessarily just strictly limited to security, but they also encompass other issues that commonly arise in code bases as well. And then finally, there's the venerable OWASP top 10, which I'm sure people have like jammed down your throat at least once in an annual security training. I'm not going to do that in this presentation, FYI. But just some background on the OWASP top 10. It's basically a regularly updated compilation of the most common security flaws in web applications. And so this was actually just revised last year. This was the previous revision from 2017. This is the 2021 revision. And you can see how things kind of shift around. Some categories get combined, some new categories get introduced. And this pretty much tracks with what the security community is seeing as far as like the most common categories of flaws and kind of creating a taxonomy for those to exist in. There's also OWASP cheat sheets. So if you're not one to sit down with like a really fat PDF, you can go to a cheat sheet and basically it'll be a bite-sized, approachable explanation of a subset of the security standards that you need to look at. This is a great resource for developers. Like if you want to sit down and say, I need to be able to approach, authorization for this API that I'm designing, but I really don't know how to parse this 500-page ASVS PDF. And I just want something that's like pretty much strictly limited to like the subset of ASVS that applies to the thing that I'm trying to do. OWASP cheat sheets are fantastic. And it's super simple best practice guides that are easy for developers to understand and implement. So any questions on standards so far before I continue? Sure. Absolutely. And so that's one of the core issues in security is finding ways to not be a blocker to actually shipping the product, right? Which is unfortunately what typically happens in the space right now. But so that's, I would say, where the value of having these kinds of standards comes in, because it's like if you, for example, go to the ASVS, which I suppose I could actually, no, I'll pull that up later. But let me start my slideshow again. If you actually go there and you're following the implementation guidelines when you're actually designing that component of your application, then you know that you're pretty much going to land in a solid spot from a security standpoint. For something that already exists, I mean, you could go retroactively look at your implementation and compare it to the best practices that you're seeing in these standards. Obviously, you'd have to go back and make changes to the implementation if you find problems. But yeah, so just following best practice guidance as early as possible is the ideal case. That's not always feasible because sometimes you learn about the guidance after you've already built the thing. But in that case, we get to some of the DevSecOps stuff that I'm going to talk about later, which is also very exciting. So stay tuned for that. Yeah, sure. So we'll talk about that also. Um, as most organizations that I see, they'll do security assessments like on an annual basis because it's actually or like a legal requirement or some kind of regulatory requirement. But ideally, you're doing continuous security testing across a broad range of different types of like not just pen testing, but you're doing static analysis. You've got your like IaaS and DAS tools running. You have other things that are doing like static analysis, say, and like just code scanning, and you're aggregating those metrics together. And I'm going to talk at the end of like the last section of my presentation is all about that and how you can like aggregate metrics to basically prioritize improvements to different areas of your code base. But I'm a fan of doing that type of testing, not just pen testing. I'm not the hugest fan of pen testing because it's not the most reproducible. The coverage isn't always great. You have to test a live version of the application that may be far removed from what's currently in development, and the results and the coverage that you get pretty much depend on the pen tester that you've got doing the assessment. So they may catch some flaws in one part of it, but there could be entire other sections of the app that they didn't even touch that may have flaws in there as well, or that they don't have the skills to uncover, right? So pen testing is valuable, but it's not the only type of testing that you should be doing. And it's something that should be done in concert with a number of other types of security testing and scanning as well. And we're going to talk about that. I saw a question there too. Yeah. So one of the worst ones that I saw was for a large financial services company. And they had this online dashboard where you could talk to a financial advisor. And I found an issue in the part of their API that handles file uploads to share documents with the advisors, where you could grab anyone's documents. And so I was like getting like people's grandma's death certificates and like their 1099s and their tax returns and like their 401k information, like bank statements. And this was in production, like on their site that serves like, millions of people. And I'm like, so I immediately called them. I'm like, this is horrible. You guys got to fix this like ASAP. That was probably the worst one that I saw. That was for a customer. Yeah. No, that anyone on the site could, because and so the issue there, yeah. So the issue there, and kind of going back to what's his name, Alex's question, is they actually had authentication and authorization checks on that part of their API that they had disabled, but they did not catch that in their test suite, right? And so, that's kind of part of the issue where it's like, yes, you should be doing pen testing, but you should also have other parts of your like, just testing pipeline to basically express the policies and expectations that you have from a security standpoint, make sure that those are being applied uniformly on like really security critical pieces of the app, right? And so, yeah, that's kind of why I'm a fan of a more holistic approach. So speaking of, let's talk about threat modeling. I've been standing here talking about, threats and risks and stuff, but like, what does this actually mean? If you're going to sit down in front of your application and try to, take inventory of all the different threats that could, be presented to it, How would you do that? Well, that's where you reach for threat modeling. So how many in here are familiar with threat modeling? Maybe they've done a bit of threat modeling before. Okay, how many in here are like familiar with like systems architecture and design? Like you sit down, diagram an app out. Okay, so more of you are like, so this is pretty much in line with that, but just with the security flavor. And so the goal with threat modeling, we want to identify, communicate, and understand threats and mitigations within the context of protecting our application. So to make a threat model, we're just creating a structured representation of all the information that affects the security of an application. And we're going to use that to make informed decisions about application security risks. So going back to this slide, again, we've got the infrastructure and the assets, and we've got regulatory and compliance considerations, and we've got all the teams that support that. So if you think about, I don't know, maybe your app has some very sensitive key material, like secrets that it needs to authenticate to things. And you're like, great, I'm using like AWS Secrets Manager, Azure Key Vault or whatever. But then the people that are actually responsible for putting the secrets in there for your app to use, like they just sort of leave it on a post-it note on their car windshield so that they don't forget when they come into work, they can put it in. Like, that's why you also have to consider, like, for example, the people there. So when should you threat model? So ideally, and again, this is kind of back to that whole, when should you be doing security stuff? Ideally, you want to do this continuously because your software development lifecycle is continuous as well. So if you just make one version of a threat model at the very start, say, of a new application, that's going to fall out of date as you make changes. You release new features, or you change the underlying architecture, or migrate it to new infrastructure, what have you. Every change that happens, in the application causes a threat model to sort of drift out of date. So you want to keep that as up to date as possible throughout the development lifecycle. And the ideal approach is to define a threat model early on and then refine it throughout your development lifecycle. So a few kind of key points where you'd want to maybe revise a threat model would be maybe you design and release a new feature, or maybe a security incident occurs. So you think about like your application has been breached. So there was some sort of security issue that you did not consider in your original design. And you want to go back to your threat model and put that in so that you can actually design controls and mitigations around that. And then also down here, you want to do this anytime there's an architectural or an infrastructure change. So there's 4 basic questions that you want to answer during a threat model. So first, you want to assess your scope. What are you working on? That could be something that's as small as like a single sprint that you want to add to your updating your threat model, or maybe you need to threat model an entire system for the first time. You want to identify what can go wrong, and that could be as simple as like a brainstorm, or as structured as actually working through some of those standards and going, point by point to check each of those implementation guidelines. Finally, you want to identify countermeasures or manage risk, and then assess your work. So identifying countermeasures, that's where you're going to basically decide what you want to do about each of the threats that you've identified. And that doesn't necessarily mean that you implement a mitigation. You could decide to accept a risk, or maybe it's something, it pertains to a third-party integration. So maybe that's controlled by an outside vendor, and you just kind of transfer responsibility for managing that particular risk to that outside vendor. And then finally, when you're assessing your work in an actual, formal context, you probably have some sort of rubric or guideline that you'd follow to assess the quality and rigor of the threat model that you've produced. But in this case, like, the most general way that we could describe it, you could just ask yourself if you've done a good job to, be comprehensive enough for the system at hand, right? So first, you decompose the application, right? You want to understand the structure and the composition of it, as well as how it interacts with any external entities. So from a services standpoint, like the different services that you've got, the infrastructure the services run on, and then maybe, I don't know, any third-party APIs or things that you're interacting with, data flows, use cases for the app, and so on. Then you're going to determine and rank threats. We'll be using Stride for this. I'll go over Stride on the next slide. But you can use any threat categorization methodology that you want. And in this case, the goal is just to identify offensive and defensive threats. And when you're determining the threats in the decomposition step, that's basically going to help you work backwards to find what the attacker targets could be. And you can then take those threats that you've identified and categorize them based on whichever standards that you're following. So the STRIDE framework, this is something from Microsoft. There were some of the early kind of progenitors of threat modeling. To follow STRIDE, all you do is decompose your system into components, analyze each component for susceptibility to threats, and then mitigate them. And you repeat that until you're comfortable with the remaining threats. And if you do this, you can argue that the system is secure, basically. What does STRIDE stand for? You've got the types. So each letter of STRIDE is a type. So S is spoofing. That's any kind of threat action that's aimed at accessing or using another user's credentials, basically. That's authentication related. Tampering is any kind of like threat action related to maliciously changing or modifying persistent data. So you can think about tampering with database records or files on disk or any kind of persistent data that you're keeping track of that's related to integrity. You've got repudiation, which is aimed at performing prohibited operations in the app. So maybe you've got a user of a particular role that's able to do something outside of the scope of what their role should allow them to do. This is related to non-repudiation. Information disclosure, which is, if you're able to say, read a file or get metadata that you're not supposed to have access to. Denial of service would be denying access to the app. It could be network attack, like related thing, or it could be like, say a regex DOS or like a billion laughs kind of thing. And then there's elevation of privilege, which is, say a user being able to elevate their level of access to a higher level. So once you've got vulnerabilities, you design countermeasures. And it's common that you would use lists that map threats and risk rankings to their associated countermeasures. Again, that's where you could whip out ASVS and say, we've got authorization-related problems. What kind of countermeasures can we actually employ to solve some of these authorization-related issues? And then you can start sorting these in terms of priority, because if you've got a pile of risks, then you want to know what you should work on first, and that's where you get into prioritization. So one useful resource that exists is the OWASP Threat Model Cookbook. So this is actually a collection of threat models that OWASP has created that you can go and study if you wish. They don't prescribe any particular methodology for the threat modeling itself, but you can examine basically this set of curated examples and apply any of those that you want to it. So here's some examples of what threat model diagrams look like from the OWASP cookbook. You can see it's really basic. You just sort of have trust boundaries, which are these dotted lines. You've got any kind of data store is represented as this rectangle. Processes are circles, and actors are squares. And sometimes the circles and the squares get interchanged. In this case, this is like a really simple web application. You've got a web server, you've got a user, here's a CDN, and here's an administrative user, and there's a database, right? And these kind of grow in scope and complexity as apps get more complicated. So like this, I would think is an IoT device of some kind. Yeah, right here. It has a local API. There's a user that can talk to the IoT device through like a script or a mobile app or a browser. Here's the backend for the cloud service that runs the IoT device over here. And the idea is, again, you want to have a structured representation that you can actually look at and examine and start thinking about how data flows through the system and what components of the system can be interacted with. So in this case, here's a user, here's an employee of whatever company runs the backend. You can see that they're able to talk directly to this database, whereas this external user on the public internet is not able to, right? So any questions about these diagrams? Go ahead. A library? Yeah. Yes. We're going to talk about that. That's one of the examples in this last section. I'm excited to talk about exactly that. But so what kind of what would be an example of a library you want to? Mm-hmm. Yes. Mm-hmm. Yes. So we're going to talk about metrics, which plays exactly into your question. So what are the metrics that we use to actually kind of judge application security? So here's four of the most rudimentary kind of core ones. The first is code coverage, right? So how much code do our assessments cover, whether that's pen tests, whether that's any kind of scanning, static analysis, et cetera. You've got defect density. So you're building on the coverage. So you're saying on average, right? How many vulnerabilities exist per n lines of code in whatever thing that we're examining, right? And that's where you look at, say, like code smells. You've got mean time to detection. So the question that's asking is, how quickly do we detect vulnerabilities through any of the methods that we have in our scanning and testing pipelines? And then building on that, you've got mean time to remediation. So the question that's answering is, how quickly do we remediate vulnerabilities after discovering, right? So these are all pretty important. When you're thinking about health of your application security program, when you track mean time to detection and mean time to remediation, and basically even the total number of open and closed vulnerabilities over time, you can sort them by priority. So you can say, of all the vulnerabilities that we're finding, and aggregating, how many of them are critical or high priority? How many of them exist with a past due SLA? If you've got some sort of SLA that you've set on, when findings of a particular criticality should be remediated, you can sort them out by detection source. So you can think about, how many are we finding from pen testing? How many are we finding from code reviews? How many are coming in from upstream dependencies or third-party components, from static analysis, et cetera? And you can also break them down by category. So you could break it down against the OWASP top 10, ASVS, et cetera. And this puts you in a very interesting position, because now when you're thinking about maturity, you can ask, like, what tools are we using and what coverage does each provide? How widespread is their use in our organization? And, maybe are there usability issues or other barriers to adoption that are preventing development teams from actually picking these up and building them into their test suites? You can also think about where you're finding most of your vulnerabilities. So like what stage of the software development lifecycle and from which tools? And does the detection point impact the turnaround time for remediation and detection, right? Those are all important considerations. So if you're thinking about feedback loops, so maybe, and this is what I was talking to Alex about. So say you're finding a lot of SQL injection vulnerabilities during your penetration tests, but you're not actually seeing those in your scanning tool chain, right? Why is that? Ideally, you'd want to catch those types of vulnerabilities as quickly as possible. And SQL injection findings are actually quite easy to pick up using static analysis techniques. So you can take basically this insight and use it to turn around and tune your scanning rule sets to close this gap and thus find those types of vulnerabilities earlier. Or say, for example, you found that 10% of your authorization-related flaws across several apps that you've got follow a consistent pattern that correlates with the use of a specific third-party dependency, right? So now you can actually say, like, okay, if we eliminate this dependency, does that mean that we eliminate 10% of the authorization-related flaws that we've got, in our backlog here? Why is it that people have issues with implementing authorization with this particular piece of code? In terms of libraries, so say, you're an owner of a given library, and you know that security issues may occur if people use the API, when they use the API basically in a way that's incorrect, right? So to help mitigate this, you can contribute static analysis rules and tests to basically build into a scanning pipeline to pick up, anti-patterns and flag them, when your API is being used unsafely. And maybe building on that, you can actually take some of the results of the scanning that you're doing and maybe do some refactoring of your API so that there are less sharp corners, so that it's less likely that people would pick it up and actually shoot themselves in the foot. So let's see, skip forward to this. And another example, say you've got a penetration test that you were doing, and you take some of the results from that penetration test and actually distill it down into static analysis rules to basically it's called variant analysis, where you're finding other instances of the same or similar type of security vulnerability across, other parts of your code base. And so that puts you in a position where it's like you're getting more value out of the pen test because you're able to find similar instances of the same type of security flaw, but you're also basically putting yourself in a position where you can prevent regressions that would reintroduce some of the same security flaws in your application in the future. And that's the whole look at application security. I know that was a lot of stuff, so mile wide, inch deep is the name of the game here. All right. So, any questions? Yes. 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 Sure, sure. So I can actually talk a bit about that. I want to do another talk on tools, but that would easily be its own presentation. But if you've ever heard of SemGrep, I think so. SemGrep is a fantastic static analysis tool. Yeah. So basically, you can write rules in YAML that this tool SemGrep will run against your code base to identify, certain security flaws that may exist. So say like you're using a like Django, right, to build a web application, and you're setting a cookie, right, and you're calling the method that lets you set the cookie, but you don't have like the HTTP only flag set on the cookie, right, when you're actually doing that in your method call, would be an example of something that you can identify using SemGrep. So you can do much more advanced things with this. This is just a kind of a more general explanation, but the idea is you can actually analyze the code itself, and you can express security policies or like properties that you want your code to have, like from a security standpoint, as code in YAML rules that this tool consumes and then executes against your code base to do scanning. You can do much more advanced stuff. So if you're familiar with like taint analysis, for example, you can track, say, the usage of a variable or the usage of an instance of an object, like through several lines of code, and seeing how it's being like permuted or used to match against different rules that you've written. The other thing that's really nice about SemGrep is that there's a huge list of community contributed scanning rules that I may or may not be able to easily pull up. This is semgrep.dev, by the way, if you want to pull this site up. But basically, for all different types of languages and frameworks and things that you could potentially work with, there's a huge repository of rules that is continuously growing and contributed by the community around SemGrep to basically let you point this thing at your code base, even without any configuration, and it'll just run and identify all types of flaws. Yeah. Yeah. So static analysis relies on looking at the code itself, like, or maybe you're looking at a compiled binary, right? With debug symbols in there, or maybe you're looking at it with the source code as well, but you're not actually running it. So dynamic analysis would be you've got the app deployed and running somewhere, and you're testing its behavior at runtime, right? So you're feeding it different types of data, maybe you're fuzzing it, or running some kind of scanner against it. That would be dynamic. This is static. Yeah, yeah. And the other thing that's nifty about SemGrep is that it emits metrics in JSON that you can then aggregate into something like Defect Dojo. This is a really nifty tool. I want to do a whole different talk on tools, but this is basically like a dashboard that lets you manage and analyze all of your different application security related metrics into a single UI. And this is a very small screenshot. There we go. But you can see, for example, like you can break down based on the severity of a finding, different metadata about a particular finding, the description of the finding. This is actually showing you based on like which languages are in use in the code base and the number of like vulnerabilities in the files and the technologies in use and so on. So this is a very powerful dash kind of if you think about like business intelligence tools, this is one that's specifically about aggregating application security metrics, and it's completely free and published by the Open Web Application Security Project. But that's something that you could, for example, pipe SemGrep's metrics directly into and get a visualization. So, Vince, sure. Mhm. Managing API keys, like say you've got a secret that you bundle into the app to reach some kind of API. Is it like secrets management internally, or is it secrets management for the app that you deploy? Okay. So if it's internal secrets management, like say, you, yeah, like say, it's you've got your source control for your app, and it needs to have API keys and stuff to talk to services. Just use a secrets manager. You can use HashiCorp Vault. You can use AWS Secrets Manager. You can use Azure Vault, some kind of secrets manager. Just hook that into there and keep your secrets in there. Don't actually commit them to your source control. That's a horrible idea. Um, and so that would be my recommendation from that standpoint. On the other side, um, sometimes you've got like say mobile apps or just like a single page app that has an API key to some service it needs to interact with. Um, and you don't want to actually expose API keys in like a bundle that you deploy publicly because it's trivial to extract and someone could actually take that and use it. In some cases, like on the Google Maps API, you can restrict the use of particular API keys by origin. So say like it you would have a website that's got like an embedded thing that uses the Google Maps API, and you've got it restricted such that that key is only accepted by Google when requests are coming from your site's origin. So someone else couldn't just like pick the key up and use it on their site and like take advantage of your API quota. But the on the other side of it, what I recommend would be something called PKCE, which is proof of key code exchange. And this is actually an OAuth like flow, like an extension to the OAuth standard, where basically you can do authorization like through OAuth without actually bundling in a static secret in your bundle. Like it's just generated basically dynamically at the time that this flow is kicked off in the user's app. So that would be my recommendation for those different approaches in those vastly different contexts. Yes. Yeah. And it protects against certain types of like hijacking as well. Yeah. So stuff. I like that. Any other questions? All right. Um, yeah, it's sort of. It's similar in principle. Like if you're familiar with like checkmarks, SonarQube, Veracode, SemGrep is a lot more flexible and it's also open source. And there's a much more kind of diverse and growing set of like rule sets that you can use with SemGrep as opposed to something like Veracode, which has very specific requirements for the types of applications it can analyze and like what you have to feed it to be able to do the analysis. Like SemGrep is much more flexible and forgiving. External tools such as that's okay. Um, if you're looking for tools to do like scanning, it kind of depends. There's a lot of tools that can do like dynamic security scans for you, and that could be something as simple as like you just use the burp scanner. Are you familiar with burp suite? It's like an intercepting proxy with a UI that has a bunch of security stuff built into it. And you can like click a button and it'll send a bunch of garbage and like security tests to any endpoints on the application that it's seen that can like accept data, whether that's like post parameters or like a like query parameters or whatever. Mhm. Yeah, and they vary widely in terms of like price. So like some are multiple thousands of dollars and some are free, and it kind of just depends on your use case. I will. Go ahead. Hmm. 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 Yeah, they're just gonna their eyes are gonna glaze over. They're gonna tune it out. So I always kind of start from the more holistic view because it kind of ties the picture together. It's not like you're just giving someone a list of like this is a problem and this is a problem. Like you're trying to put it in context in terms of like you have a responsibility as a developer to make sure that our customers' credit card numbers do not leak online, right? Um, so probably from that standpoint, like managerially, uh, instilling a greater sense of responsibility is probably important and would get them to care more. And just trying to communicate more on their terms about what uh, what these different types of flaws are. Because again, it's like if I just stand in front of a developer and give them a bunch of security jargon, they're not really going to care and they're going to kind of glaze over. But if you more tailor it to their needs and like their workflow, then they'll probably be more open to getting that feedback. So that would be my two main recommendations. I mean, also if you show them a bunch of like really severe security issues in like an app that they're working on, you can be like, we've got to really intervene and like fix all this stuff. So yeah. Anybody else? Yeah. Yeah. Well, so I kind of have a love-hate relationship with the idea of security training for developers because it's like on the one hand, you want them to be aware of security issues, but on the other, it's like you can't expect them to drop everything and become a security expert just to understand like the feedback that you're giving them, right? Ideally, we want to take as much of like the different application security needs that we have and turn them into automation so that like that can just run in the background, say like as a developer is actually working on an app, whether that's like in their IDE or that's like when they're committing code or like during like the testing pipeline that they've got set up. Like that's all great, but you can't just sit and expect, okay, we're going to make every developer a security expert so that they never make another mistake again, because that's not possible with anything. So awareness training is good, but I think it's also really a question of like fitting the tools and like techniques into their workflow better. You know, send me an email. Yeah. Um, do you have that? Can you just post that? Okay, very good. I saw another hand go up. I can't remember who it was. Okay. Any other questions? Sure. Yeah, so you can follow it. InfoSec like has a big community on Twitter. Is kind of one of the places that they really gather around. Conferences are good. Uh, if you read write-ups, from people doing like different types of CTFs or like bug bounty reports, stuff like that, those can be really valuable for new types of tools and techniques. You can look at subreddits or like Hacker News or stuff like that, and sometimes there will be security content that comes up. But in general, I mostly recommend looking at like write-ups because that's people actually doing, bug bounties and stuff where they identify and exploit flaws that may be novel to you. Yeah. So if you look at CTFs or you do a lot of CTFs, if you Google the name of the challenges, from a given CTF, you'll find write-ups. Uh, that's a great way. Otherwise, there are just like blogs that you can find where people do a lot of like HackerOne write-ups or just bug bounty write-ups in general. Or I think even if you go to like the bug bounty, like say if you go to HackerOne, sometimes they'll publish like write-ups that for bugs that were found and submitted through their platforms. Yeah. Another one, there's a lot of great mailing lists for security. So OSS Security is one. Uh, there's a bunch of other ones, and I just subscribe to those. And anytime there's like a message that pertains to a piece of software that like I'm familiar with or I use, I'll read the mailing list message. But those are actually surprisingly quite active. Yeah. So there's a great podcast called Security Cryptography Whatever, which is fantastic. That's like my favorite security podcast. Other people listen to. I know that Risky Business is a popular one, and Darknet Diaries is another one. Those aren't my favorite. I like the more technical ones. So Security Cryptography Whatever. That's the one. And they're big on like cryptography engineering, but like not like the bullshit like blockchain cryptography, like actual like they're gonna talk about like NIST P curves and stuff. Yeah. All right. Anything else? All right. Well, it was an absolute pleasure sharing all this with y'all, and hopefully you've learned a lot about application security.